Hello YouTube, welcome to Basic Chemistry 3rd SAT Chemistry video, and in this video we're going to cover the true and false section of the exam of the 1994 or the 1998 exam. So to briefly explain what this section is, in this section you're basically given two assertions or two statements, and you're supposed to identify if statement 1 is false or true, or statement 2 is false or true. And if both of them are true and they have a cause and effect relationship, then the answer would be true, true, and cause and effect. But if they're both true and they do not provide an explanation for one another, the answer would be just true, true. And if the first statement is true but the second statement is false, the answer will be true, false. And if the first statement is false and the second statement is true, it'll be false, true. And if they're both false, it'll be false, false. Now, the format of the old exam is a little different, so you're required to write letters and put the corresponding letters as answers. But in the more recent exams, you're actually given a separate answer sheet, or a portion of the answer sheet is dedicated to this portion. So you kind of give like bubbles that you fill out. So this is like true F, and like CE. It's a little different, and we will follow that format in this video. So let's get into it. Number 24. Oxygen is an element. That's definitely true because it's in the periodic table. Because oxygen exists in the form of diatomic molecules at room temperature and atmospheric pressure. So this statement is true. Because oxygen does not exist as just it's a diatomic molecule and always exists at O2. So this is also true. However, they do not provide a cause and effect relationship because oxygen, being a diatomic molecule, has no relationship to it being an element. So it's just TT. So number 25. A saturated solution may be quite dilute. That's true because some substances have a very low solubility. Now, this is also true, and that is because saturation and concentration are two different things. So that's saturation and concentration. So saturation, if a solution is highly saturated, that means no more solutes can dissolve in the solvent. And if it's unsaturated, that just means that more solutes are still able to dissolve in the solvent. And concentrated just means the number of the molecules of solutes in the solvent. So if it has a high concentration, that means there's a lot of solute in the solvent, and that does not necessarily mean. So saturation and concentrations are not always related. So for example, let's say that you have a beaker and you put in a solid piece of titanium. Let's say titanium. So you can say that this solution is already saturated. Why? Because you can't dissolve more titanium in this water, and the titanium you already have in the solution is all that there can be, or rather it's the maximum amount. So we can say it's saturated. However, it's not concentrated, it's still dilute. Because the solution does not have a lot of titanium ions, or rather titanium atoms, it's still a solid piece of titanium, and the volume taken up by the titanium is relatively little compared to the overall volume of the solvent. So a solution can be both saturated and dilute. Therefore, second statement would be correct, and it would show a cause and effect relationship. Because as stated before, something like titanium have very low solubility. Okay, number 26. C14 is an isotope of N14. Oh, so that's not true. For two substances to be an isotope of each other, they need to have the same number of protons and electrons. So let's see. So we know that carbon-12 has 6 electrons, 6 protons, and 6 neutrons. And carbon 14 also has 6 electrons, 6 protons, and 8 neutrons. So only everything should be the same. However, in this case, although the mass number or the atomic mass are equal, nitrogen actually has 7 electrons and 7 protons, so this statement should be false. Because C14 and C14 have the same number, yeah, that's true. So it should be false true. Number 27. A catalyst accelerates a chemical reaction. That's true. So basically there are about 5 things that affect the rate of reaction. And the first one is pressure. Second is temperature. Third one is nature of reactant. And the fourth one is presence of catalyst, and the fifth one is surface area. So if you have a catalyst, let's draw a diagram here. So let's say there's a reaction like this, and so this bump you see here is the activation energy, and this is the enthalpy value for the reactants, and enthalpy value for products, and this is, and from here to here is the change in enthalpy. So let's say that this line you see right here is before a catalyst is added, and after a catalyst is added. So what a catalyst does is it slightly lowers this activation energy, which means that the reaction can happen when a lower amount of energy is given. So because the activation energy is the energy required to start a reaction, the lower the activation energy is, the faster the reaction will occur. So a catalyst definitely does increase the rate of reaction, and which is the same thing as accelerating it. Okay, so that's T. Because a catalyst decreases activation energy for a chemical reaction. So we just explained that. Should you see? Number 28, sorry. An endothermic reaction has a positive H plus value, a positive enthalpy value. That's true. In an endothermic reaction, the total enthalpy of the product is greater than that of the reactants. So this is also true. True to C. And that is because if we just draw the diagram again. So we're talking about an endothermic reaction. So endothermic reactions are reactions that require energy. So their activation energy is going to be significantly higher than their exothermic counterparts. And this is going to be the activation energy. For the endothermic reaction, the activation energy is significantly higher, as you can see in this diagram. So in an exothermic reaction, the diagram kind of looks like this, and activation energy is tiny. Because most endothermic reactions all exothermic reactions are spontaneous. But in this case, no, endothermic reactions have very high activation energy. And same as before, this is the reactant, and this is the product. And we can see that the enthalpy value of the reactants is significantly lower than the enthalpy value of the product. And that's because if energy is added, so for an endothermic reaction to occur, add energy. So if you have substance X that has very low energy, but you add energy to this, and what will happen is that the energy will increase in energy. So that's what happens here. So basically, because you add energy, the enthalpy value of the product is higher than the reactants. So let's just give an example. So let's say H2O. That gets decomposed into H2 and O2, and put 2 there. So the enthalpy value of the H2O will be much lower than its products. That's because energy has to be inserted to break the bonds. So the enthalpy of the H2 and the O2 are higher. Let's get back to the question. So we know that it has a positive delta H value because delta H of reactants of a reaction is the enthalpy of product minus enthalpy of reactants, and because the product is bigger than the reactant, of course we know that this result will be positive. So that's true for number 28. And in an endothermic reaction, the total enthalpy of the product is greater, and as I explained before, because the product is placed higher, it has more enthalpy, more heat energy than the reactants. So that also should be true, and it's a cause and effect. Number 29. Molten potassium chloride is a good electrical conductor, and that's true. The melting process frees the ions in potassium chloride from their fixed positions in the crystal lattice. That's also true. And that's because potassium chloride, or KCl, is an ionic substance. And we should all know that solid ionic substances are not electrical conductors. However, liquid ionic substances, or solid ionic substances that has been melted, are good electrical conductors. So in this case, the first statement would be true because it says molten potassium chloride, and that's because an ionic substance, or potassium chloride, is an ionic compound made out of the K plus cation and the Cl minus anion, and when they're melted, let's say we have molten KCl, and the solution will basically be rich in K plus and Cl minus ions. That's what happens when an ionic substance melts, so that's also true. Number 30. Hydrogen chloride is a polar substance. That's true. Oops, I should use black. Because hydrogen and chloride have the same electronegativity. Now that's definitely false. And that is because HCl, or hydrogen chloride, kind of looks like this. So hydrogen chloride is definitely a polar substance because the electronegativity for chlorine is much higher. And the definition for electronegativity is an affinity an atom has for an electron. So basically it means, if an element or an ion, if it has high electronegativity, so high En, that equals to wanting electrons. Now, we all know that atoms wish to fulfill the octet rule, which states that the valence shell should always have 8 electrons, and because Cl has 7 valence electrons, it dies. It dies for another electron. It dies to add 1 electron to its valence shell. So it is very electronegative. And in fact, all halogens, so all fluorine, chlorine, bromine, and iodine, are electronegative. That's definitely true because chlorine is much more electronegative than hydrogen. Oh, and another thing that you guys can remember is that in the periodic table that looks something like this, electronegativity increases as you go from top right. So the most electronegative elements, actually no, you should exclude noble gases because Noble gases already have a full shell. So excluding noble gases, fluorine will be the most electronegative element because it's in the most top right-hand corner. And the least electronegative will be francium. And yep, so it's definitely polar, and because hydrogen and chlorine have the same electronegative, and that's not true because chlorine has 7 valence electrons while hydrogen just has 1 valence electron. So they definitely do not have the same number of the same electronegativities. Number 31, ice is less dense than water, and that is true. Water is a unique substance where its solid form is less dense than its liquid form, because in most substances its solid form tends to be denser than its liquid form, but water, that's not the case. So that's true. Oh, and a further elaboration to that is because when water freezes, its intermolecular forces, or the hydrogen bond, takes place. So the O is slightly negatively charged and the H is slightly positively charged because of the electronegativity of the O's. So this actually sticks to another hydrogen, like so, and that continues. So another hydrogen sticks here, and yeah, so basically because this happens, it kind of creates this beehive-like shape. So when this shape is created, obviously the middle parts, like these parts here, are empty, which makes it less dense. I'll try to put a picture of what water molecules look like in ice, so that you guys can understand it easily. Now, ice is less dense than liquid water because water molecules are non-polar. That's false. We know that water molecules are polar because oxygen is much more electronegative than hydrogen, therefore the electrons are pulled toward the oxygens. So it's definitely polar, so that's false. Let's move on to the next section. Now, I have written the answers here. I'll erase it first. A 0.1 molar solution of acetic acid. So 0.1 molar solution of acetic acid is a poorer electrical conductor than 0.1 molar solution of hydrochloric acid. That's true. At the same concentration, the number of acetic acid molecules that ionize in water is less than the number of hydrogen chloride molecules that ionize in water. That's true. And that's because acetic acid is a very weak acid. So acetic acid, compared to hydrochloric acid, weak, and HCl is very strong. And one of the properties of strong acids is that their ions completely dissociate in an aqueous solution, which means that when 100 milliliter of HCl is added, all of that 100 milliliter of HCl is separated into H plus and Cl minus ions, while in a weak acid like COOH, so in acetic acid, it's H plus and C2H3O3 minus, and it does not fully dissociate. Let's say 100 milliliters of acetic acid is added, only 50 milliliters of it would dissociate, and because weak acids do not fully dissociate. And if more ions dissociate in water, like so, they will be a better electrical conductor, because more ions in water, more positive cations and negative anions in water, means that the solution will be better in better in conducting electricity. That's definitely true. Covalent bonds are broken when sugar are dissolved in water. Because in molecules with covalent bonds, electrons are shared by two or more atoms. That's true and that's false. And that's because, let's say, sugar, or rather sucrose, has a chemical formula of C12H22O11, and when it dissolves in water, Now, the bonds being broken are not the bonds in between these carbon and hydrogen, oxygen, because those are intramolecular bonds. And intramolecular means between atoms, and intermolecular means between molecules. So the bond being broken is not the covalent bond, but rather the intermolecular force of the of sucrose, which is dipole-dipole attraction and London dispersion forces. So it's not a covalent bond that is being broken. And the second statement, covalent bond is a bond where electrons are shared. That's definitely true. So in something like N2, 3 electrons are shared. In something like F2, 1 electron is shared. So yeah, that's covalent bond. That's true. Sodium chloride is effectively used to melt snow and ice. That's true because sodium chloride melts at high temperature. That's also true, but that's not why sodium chloride is used to melt snow and ice. It's not because it has a high temperature, a high melting point. So let's start with the first statement first. Sodium chloride is used effectively to melt snow and ice. So you don't really need any chemistry knowledge to answer this question, because if you live in a country that has winter, you would know that oftentimes people sprinkle salt or sodium chloride on snow to melt it. So that's definitely true because sodium chloride melts at high temperature. So sodium chloride is an ionic substance, and because ionic bond is often considered as the strongest in intramolecular forces, a really high melting point. High melting points. So that's definitely true. The O2 ion, or the oxygen anion, and the neon atom have similar chemical properties because the O2 minus ion and the neon ion and the neon atom have the same number of electrons. So this is true because oxygen usually has 8 electrons, but in this case it's O2 minus, so it will have 10 electrons. And neon, a noble gas, also has 10 electrons, so that's definitely true. However, the first statement, although the O2 ion and the neon atom have the same number of electrons, they do not necessarily have the same chemical properties. And that's because neon is a noble gas, and noble gases are very stable, while the O2 minus ion is just an oxygen atom that has gained 2 electrons. And compared to a noble gas, it's less stable. 36. At low temperatures and high pressures, gas tends to condense. True, because gases expand to fill a container in which they are placed. Now this is also true, and that's because the first part of the question can be inferred from the distillation setup, which kind of looks like this, and you have this tube going here, beaker, and you have cold water. So in the distillation setup, let's say you have alcohol and water, and you use fractional distillation to separate these two. So you will see like alcohol fumes going up and traveling this tube, which is filled with cold water, and the alcohol will eventually condense back to liquid. That's because at low temperatures, at low temperatures, atoms and molecules move slower than at high temperatures. So in the gas, say this is the gas, and atoms move in random motions. And when it's heated, the atoms are given energy. So they want to exert this energy by moving around really fast. However, when heat is taken away, or they're put in something cold, they will slow down, move very slowly. And when they move slowly, they will turn into a liquid, because a liquid has less random motion and less motion of atoms and molecules compared to gas. And condensation is basically when gas turns liquid. Oh, and this is the same logic as when your car windows, when condensation sometimes happens in your windshields, because temperature inside your car and the temperature outside your car are drastically different. So this usually happens in the winter times. So number 37, the compound sodium hydrogen carbonate or NaHCO3 can act as a Bronsted-Lowry base or Bronsted-Lowry acid, because the hydrogen carbonate ion can either accept or donate a proton. Now this one, you gotta know what a Bronsted-Lowry base and a Bronsted-Lowry acid. So Bronsted-Lowry base is technically a base that accepts protons, and a Bronsted-Lowry acid is something that donates protons. So this question is asking if NaCHO3 is amphoteric, which means that it can be both an acid and a base. And this is true because bicarbonate or NaHCO3 is definitely amphoteric, as it can accept and donate a proton. That's true. Because hydrogen carbonate can either accept or donate. That's true. And it should also be a CE, because the reason NaHCO3 is amphoteric is because they can accept or donate a proton. Number 38, fluorine is a weaker oxidizing agent than chlorine. Now this we know definitely is false, because fluorine atoms are larger than chlorine. That's also false. Now in halogens, and let's just look at alkali metals for reference. So alkali metals, as you go down, it becomes a stronger reducing agent, which means that it tends to lose its electrons easier. Therefore, it gets more reactive. But for halogens, that's not the case. For halogens, electronegativity increases and reactivity increases as you go up. That's because for halogens, a halogen that wants an electron more tends to be more reactive, and that is because a fluorine ion, its electron or its atomic radii rather is much smaller than chlorine, bromine, or iodine. Therefore, it can attract a electron slightly more because of the positive charge in its nucleus. So that's why fluorine should be more electronegative than chlorine, bromine, and iodine. Because radii of fluorine is indeed the smallest out of these. It should be something like this. And that's because the first rule you want to remember about atomic radii is that as you add electron shells, atomic radii increases. So in case of fluorine, there's 1, 2. In case of chlorine, there's 1, 2, 3. In case of bromine, there's 1, 2, 3, 4 electron shells. For iodine, there's 5. So fluorine is definitely smaller. Number 39, a solution with pH 5 has a higher concentration of hydronium ions than one with pH 3. This is false, because pH is defined as negative log H+. This is true. Now let's see why this is false. So the formula for pH is pH equals to negative log of H+. And a solution that has a pH of 5 should have 1.0 times 10 to the power of negative 5 H plus concentration. For a pH of 3, 1.0 times 10 to the power of negative 3 H plus concentration. Now, if a solution has excess hydrogen ions, or if it has more hydrogen ions, it tends to be more acidic. So, which of these two values are smaller? The first one or the second one? So obviously the first value is smaller, the second value is bigger. and a bigger value means it has more hydrogen ion concentrations. So the answer should be false for that one. And because pH is defined at negative log H. The second statement is definitely true because this is just one of the things that you need to memorize, one of the formulas that you need to memorize to score well on the exam. So in the next video, we will cover the part C, or the word problems, the lengthy word problems, which are a bit more difficult, but we will do that in the next video. And if you have any questions or any critiques about this video, feel free to leave a comment below, and I will try to get back to you as soon as possible.